Welcome to this explainer. Today, we're going to explore an absolute marvel of modern engineering that most of us interact with literally every single day, yet entirely take for granted. We're unpacking, pun absolutely intended, the invisible science, the massive industrial machinery, and the incredibly complex chemistry that protects our entire global food supply.
Think about it for a second. We almost always view empty boxes, plastic films, and metal cans as just garbage once we've eaten what's inside. But I want to totally reframe that for you. That discarded material, it's not just a wrapper. It is a highly engineered survival suit. It was specifically designed to navigate an incredibly treacherous global supply chain, fighting off microscopic enemies, extreme temperatures, and physical impacts, all just to deliver that food intact right to your plate.
Okay, let's dive into this. Here is our roadmap for today. Number 1, the science of containment. 2, heavy-duty thermal processing. 3, form, fill, and seal. 4, modified atmosphere packaging. And finally, number 5, active and intelligent systems.
Let's kick things off with Section 1, the science of containment.
Before we get to the advanced machinery, we really need to establish a baseline. Far from being just a passive shell, packaging is an active bodyguard. Food is under constant assault from the absolute second it's harvested or processed. You've got biological threats like spoilage bacteria and molds. You've got chemical threats, like lipid oxidation driven by light and oxygen, and of course, physical threats from the crushing mechanical stress of warehouse stacking and bumpy transit. The packaging system is literally the only thing standing between the product and total deterioration.
Moving right along to Section 2, heavy-duty thermal processing.
So, moving from the abstract concepts of protection, let's look at the industrial muscle. The crucial point here is the stark contrast between how we used to do things and how modern, high-speed lines actually operate. In traditional canning, you seal the food inside the metal container first, and then you subject that whole unit to extreme heat in a batch retort to kill off pathogens. But with modern aseptic processing, think of ultra-high temperature or UHT milk, you sterilize the liquid food and the packaging material entirely separately. Then you bring them together and seal them inside a completely sterile environment. By removing the packaging as a barrier to heat transfer, you get much faster, continuous line speeds, and honestly, much better tasting food.
For foods that are processed inside the can, the machinery is absolutely staggering. Just look at the scale of this reel and spiral cooker cooler. It's a continuous thermal processor where cans enter and are carried through the system on a massive spiral track. What's brilliant here is that the machine uses forced agitation. Basically, by rolling the cans as they move through the high-heat environment, the liquid inside sloshes around, which allows the heat to swiftly and evenly penetrate right to the thermal center of the food. It is incredibly efficient.
Now, if that last machine looked impressive, get a load of this hydrostatic cooker cooler. I mean, it kind of looks like an industrial roller coaster, towering multiple stories high. But it's actually an intricate microbe-killing machine that uses massive columns of water to create the extreme pressure needed to reach sterilizing temperatures. Unlike the spiral cooker we just saw, there's almost no rotation here, just a gentle half-turn as the carrier bars move between the heating and cooling chambers. That makes it the absolute go-to thermal processor for thicker foods where rotational agitation just wouldn't work at all, like dense meat products or solid pet foods.
All right, on to Section 3, form, fill, and seal.
Let's pivot away from those heavy thermal behemoths for a second and look at nimble assembly lines. The form, fill, and seal process, or FFS for short, is really the heartbeat of modern flexible packaging. Instead of shipping millions of empty, pre-made containers, factories use massive, continuous, flat rolls of plastic film. The machine physically forms the web of film into a pouch or a thermoform tray right there on the line. In a fraction of a second, it fills that newly formed cavity with the product and then hermetically seals it shut. It's a seamless, continuous flow of creation, filling, and securing.
And this brilliantly illustrates the mechanical choreography of that exact process. On a horizontal flow wrap machine, notice how the flat web of material from the roll is pulled right through a forming collar. It basically wraps into a continuous tube around the solid product. So think of a chocolate bar or biscuit sitting in a tray. A seal is pinched underneath, and then those rotary end crimpers spin down. They simultaneously heat seal the ends of the package and snip it away from the continuous tube. It is a mesmerizingly fast, precise, and fluid mechanical dance.
Next up, Section 4, modified atmosphere packaging. Now, what's really interesting about this is how packaging isn't just physical barriers and heat sealing, it is literal chemistry acting as an invisible shield. Take a look at these highly specific engineered gas mixtures. Before a package is sealed, the ambient room air is evacuated and completely replaced. Look at raw red meat, for example. It gets blasted with 70% oxygen to keep the myoglobin oxygenated, which retains that appealing bright red color you look for at the store, while the carbon dioxide inhibits bacterial growth. But then look at cooked meat. It gets zero oxygen to prevent rancidity, relying instead on 70% nitrogen as a sort of inert filler just to keep the package from collapsing. It is completely custom-tailored.
Finally, Section 5, Active and Intelligent Systems. This brings us to the real climax of our explainer. We're moving beyond passive barriers and static gas mixtures into completely dynamic systems. These are active packaging systems, literal chemical bodyguards embedded directly into the film itself or inside small sachets. If oxygen leaks into a package of fresh pasta, iron powder scavengers will aggressively react with it, neutralizing the threat before it degrades the food. If ripening fruit exhales too much ethylene gas, potassium permanganate scavengers absorb it to prevent over-ripening. There are even films loaded with silver zeolite that actively release preservatives onto the surface of the food to stop microbial growth. The package is fighting a continuous, active battle on behalf of your food.
Taking things one step further, we have intelligent packaging. Rather than just fighting off threats, these systems act as active diagnostic monitors. They can actually track the temperature history of a chilled product or react to specific spoilage compounds inside the package, physically changing color to signal a breach in safety. They communicate the product's entire history directly back to the supply chain and ultimately to you, the consumer, ensuring absolute, foolproof quality control.
Let's bring this all together and see how this builds into the everyday conveniences we completely take for granted. All of those towering hydrostatic cookers, the high-speed form-fill-seal robotics, and the invisible modified atmospheres. They all culminate right here. A thermoformed paperboard or plastic tray sitting in your fridge, perfectly preserving a complex ready meal. And thanks to advanced material science, that exact same protective barrier can transition straight into a microwave or radiant oven, withstanding 200 degrees Celsius to cook the food perfectly.
It's honestly incredible to think about the journey our food takes, and the invisible survival suits making it all possible. As active scavengers and intelligent sensors become more and more integrated into the very molecular structure of these materials, we really have to wonder, will the packaging of the future be smarter than the food it protects? I hope this explainer has completely transformed how you look at the engineered marvels sitting on your grocery store shelves. Keep learning, and I'll catch you in the next one.
Industrial Bakery Simplified.